Good morning. See, here I am on my chat while I'm recording, but I'm on mute. So if you join there, that's cool. You won't hear me talking because I'm talking here. These are my solving radical equations notes. We're not too far off of normal pace, which is pretty surprising because you never know how the years are going to work out. At any point that you need more examples, just ask. So what you must do when you're solving a radical equation, and the title radical equation insinuates that there is an equation with radicals in it. I think that's probably pretty obvious to you, but you must isolate the radical first. Okay, it has to happen. I'm not going to make this an assignment to copy these down, but it's not a bad idea. So you have to get the radical alone. If there are two radicals, well, you just need to isolate one of them. So some radical has to be by itself. Okay? What you do then, once you've isolated the radical, is you have to raise each side of the equation to a power equal to the index. And the index is the little thing that indicates whether it's a square root, a cube root, or even a fourth root. We won't go as far as fourth roots. But the index here would be 2, and the index here would be 3. So that's what you're going to raise each power to. Then you're going to solve and check, because you might have an extraneous root. Okay, those are solutions that don't really, oops, I already wrote the word roots. But they're solutions that don't really exist, but they look like they will when you're solving it. Okay? So for example 1, you can see the radical is not isolated in that form. So I'm going to get this whole thing by itself by adding 3 to both sides. So my radical now is by itself. And now that it's by itself, I'm going to raise it to the second power. In other words, square it. You know that once you square a square root, it's going to eliminate that radical sign. So you get x equals 58. When you go to check these, you have to check them, okay? You know me, I haven't always mandated that you write out the checks, but 6 plus 58 is 64. 8 minus 3 is 5. Yeah, that works. So that's enough of a check. In school, I would ask you to check them because you'll see what's going to happen. Example 2, you have the cube root of 2x minus 3, and it's equivalent to negative 3. So to eliminate the cube root, I am going to cube it. Negative 3 times negative 3 times negative 3, sorry, my foot's in the picture there, is negative 27. I'm going to add 3 to both sides. So I get x equals negative 12. Well, I should have put this in a pretty solution set. I'm sorry. It's a little different at home. My formalities here. When you plug negative 12 in, 2 times negative 12 is negative 24. Minus 3 is negative 27. Oh, yep, that works out. So that's the idea that you want to do there. So the solution is negative 12. Number 3. So I have the square root of 2m plus 1 plus 10 equals 6. So to isolate, I am going to do that. So 6 minus 10 equals negative 4. Now, some of you may be able to see here that you're not going to take the square root of something and get a negative. Okay, so automatically I have an alarm going on in my head. However, if you just follow the steps, you will see that you get 2m plus 1 equals 16. So 2m equals 50. Then you're like, wait a second, Mrs. Collins, you said there wasn't going to be something that works. This 7.5 looks like it works based on the way I solved it. But when you go to check it, you're going to get, why did I write parentheses weird? I don't know why I did that. You get 15 plus 1 is 16. That can't work. This is an extraneous root or extraneous solution. It's a solution that you get and it looks like it's going to be an answer, but it isn't one. There is no solution to this problem. Nothing will work, no real root. Number 4, well, I told you have to isolate one of the radicals. This one's already isolated. Don't make your life harder than it has to be. I suppose you could subtract 2 and divide by -1 and isolate that one, but that's making your life a lot more difficult. This is isolated. So this will just come out like that. And this has to be FOILed. So this is where the problems get more difficult. So you can see I'm going to write out my work. You're squaring a binomial, which is why I'm writing it out. So I get 2 times 2. I get negative square root of y times 2. I get another one of the same thing. And then at the end I get a negative times a negative, which is a positive. Radical y times radical y is y. So now I have this equation. You can see there's still radicals left, but now there's only one radical because those are like. So we can combine those. So I'm going to set out and I'm going to do a couple steps at the same time. Because you're able to rewind the video, I think you'll be able to follow that. So there's your minus y's. Those are going to go away. I can see I have a 4 and I can do this. So I have a -6 on the left. And on the right I have a -2 radical y and a -2 radical y, which is a -4 radical y. The radical is not completely isolated, but it's isolated enough where I can square it again. So I'm going to get 36 equals 16y. So y equals 9/4. We're going to go ahead and see if it works. When I plug 9/4 in, I'm going to get 9/4 minus 2. So you can see I'm plugging it in completely to the original. So this is like 9/4 minus 8/4. If you're good at fractions, you can do that in your head. And this is, and look at that, inside the radicals you've got perfect squares, so that's a good thing for us. So you get 1/2 equals 2 minus 3/2. So 1/2 equals 2 minus 1/2. Yep, that does work. So the solution of 9/4 does work. Last problem, I have it already isolated. So I'm going to square it. This is interesting. You end up with a quadratic. So I am going to, I know when I get it in a quadratic, I have to set it equal to 0. I'm able to factor it. And I'm able to determine that x is 3. Does that make sense? 6 times 3 is 18. 18 minus 9 is 9. Square root of 9 is 3, which does equal 3. So anyway, I hope this helps. I do plan on trying to do a live class this week. I don't know if I should do it for all 3 classes of Algebra 2. I have no idea yet, but anyway, please comment and make sure that I know that you watched this. I hope you're well.